you, Drishan. So today's topic is about the counting surfaces. So it's in continuation with our broad heading, that is the visualization of 3D objects. So till now we have studied about the orthographic projections, and also this is the second part, the counting surfaces. After this, we'll look at the counting of the blocks and then the surface development. So in this, out of the broad heading, that is the visualization of 3D objects, and in our first class of this head, I told you about you can expect at least 8 to 10 or more questions from just this head about the visualization part. But from this counting surfaces, this is also important for your exam. We can even write for it that it is important for both NATA and JEE. The reason being that this is a subtopic, but still you can have 1 or 2 questions from it or more also. So on an average, 2 questions could be asked, in which they can simply ask you to count the surfaces or just to answer the number of surfaces. So for this heading, the counting surfaces, we need to understand the 3D objects. Now in the first head, in the visualization part, where you were asked for the 3D but just by looking at the 2D or vice versa, so there the object was given to you. In this heading of counting surfaces, sometimes they just give the name of that. Okay, so therefore understanding the 3D object is very important. You need to know the view of it so that you can count the surfaces. So let's look at what all things you need to keep in mind for this head. While talking about the questions part, so in your exam, in your NATA or JEE, any exam, different things is, first, let's say the 3D object is given. They give you the object or the composition or anything, and then they ask you to count the surfaces, edges, vertices, anything. The second option could be, like I just explained, that name could be given. Name means they can simply say tetrahedron. So they will say, like, tell us the number of surfaces in a tetrahedron. So you should know what a tetrahedron is. Only then you would be able to answer it correctly. Another thing, while giving such questions, you should carefully read the question statement. The reason being, though they are asking us about counting the surfaces or anything, sometimes they change the question a little bit. It's like sometimes they ask you to only tell about the horizontal surfaces. So instead of just looking at, okay, we need to count surfaces, there is a 3D figure, let's start counting. Instead of going like that, first look at what is actually asked in the question. If they have asked about only horizontal surfaces, there could be any random figure having a lot of slant surfaces, and if you start counting the horizontal surfaces, those could be like only 2 or 3 or maybe only 1 horizontal surface. So you need not to think that, okay, why they have given such a complex figure if the answer is only 1 or 2, because those are just some basic tactics that our conducting authorities use to confuse you. So always carefully read the question, what they are asking. Just a minute. So are these things clear to you? Please respond.
Yes, sir.
Okay, so these are the basics that you need to keep in mind for scoring the marks in this particular head. Now, these are the three things which they always ask about, like the faces, edges, and the vertices. So a face is simply a flat surface on a 3D shape. This is a very basic example you all are familiar with. So this is a cube. This is a face. So similarly, this side is also a face. Any of the plane surfaces, flat surfaces, those are the faces. Then an edge is where two faces meet. When this face and this face meets, so this becomes the edge. Now, just give a bit attention to the definition of these things, because in the complex figures, you should know what an edge is, what a face is, or what a vertex is. In the vertices, it is a corner where the edges meet. This edge, and the edge that is not visible. So they are meeting at this point. Or this is also a vertex. This is also a vertex. So these are the three things. In your questions, they can ask you about all three or any one of them. That's why always look at the question, what they are asking in detail. So in the given example, like this cube, tell me the value of the number of faces, vertex, and edge quickly. How many number of faces are there in this cube?
The faces are
Faces are
6.
6.
okay. Just for your better understanding, we can draw it like this. So yes, we have 6 faces, and then number of vertex.
So we have 8 vertices.
Okay, and also count the number of edges.
Sir, 20?
No.
No, sir. No.
Take your time and count properly.
5, 6,
So
7.
12.
Sir, 12.
Okay, so you guys have answered me that the edges would be 12, and then we have the vertices. Sohani, your answer for the vertex would be total number of vertices, like it's the plural.
Total number of vertices, sir.
Yes, these points where the edges are meeting.
Sir, 8.
Okay, so yes, this is the right answer. But the things you need to keep in mind, that this edge is shared between this face and this face, right? So when you get some complex figures, which I will show you in subsequent slides, so there, keep in mind that do not count one thing twice or thrice. Edges which are sharing, or the vertex which are sharing, do not count them multiple times. Now another thing, this example was based upon if an image is given to you, like this cube is given to you. Another thing is, say the name is given, like this tetrahedron. So do you guys know how much this tetra is? Like 1,
Sir,
2, 3, 4, 5, 6.
Tetra means 4.
Yes, tetra means 4, but that also means that we need to know these numbers and the name. So you can also take the notes of it, like 1 is mono, 2 would be di. These are basically the prefix. 3 is tri, 4 is tetra. So we had the tetra and then we had the hedron, that 3D part. Any guess for what a 6 would be?
Hexa.
Yes, hexa. Then 7 would be?
Octa.
No, 7, 7.
Sir,
Sept.
sept.
Hepta. Hepta, septa, both are used, but hepta is the main one. Then 8 would be
Octa.
octa. Yes, octagonal. Right. That's why these things are used. A hexagon. In your chemistry, you guys have studied about these. So these are the hexagons because hexa word is used. Those are having 6 edges. This is the significance of these names. Then we have 9 and 10. So those would be?
Nona
Yes,
and deca.
deca. But we need not, we are not done with 10 because NATA also asked for 12. NATA also asked for 20. So we need to also think about them. So what would 11 be? Okay, let me tell you about 11. Now tell me about 12. You can think like as if the counting again started. It would be dodeca. So if there is any 3D object having those 12 faces, so that would be dodecahedron. Then trideca. Then these things are same, trideca. Then we have the tetradeca. So these becomes easy for understanding and remembering. Then we have pentadeca, hexadeca. You see, from this onwards, they are using the same words. So this would be heptadeca. This would be 18 would be quickly tell me about 18 and 19.
Octadeca.
Octadeca and 19 would be
Nonadeca.
yes, and 20 would be 20 would be it won't be deca. There is new word icosa. Clear? So if any 3D object you see having 20 faces, like see the cube was only having 6 faces. If something is having 20 faces, so that would be icosahedron. So now tell me what would be the name of cube? Like we all know this figure with the name of cube, but what would be the name of it based on these things that we have studied here?
Sir, hexa.
Yes, hexahedron it would be, but hexa part you have taken correctly. It would be hexahedron. So now you know the significance of this number.
So I have a doubt.
Yes.
So in that case, we won't have a mono, that is one-sided figure, no, sir.
One-sided will become a two-dimensional. It won't
Plane.
be. Yes, it would be planar. So that is a different thing.
Okay, sir.
So from this slide, these two slides are actually very important. The first example slide is you should be able to identify the edges, vertices, and the faces in a 3D one, in an image that would be given to you. And in this second You should be familiar with all these terms. Remember,